again, what? You see the difference of squares, right? Sum of difference of squares is the trig sub, so it's a trig sub one again. You know, there is no, if there was an x on top, I'd avoid the trig sub. That's not the case. So what identity do we basically see here?
1 minus sine squared.
Okay. Right, a 1 minus sine squared. You could actually use cosine, but the standard is think it as the sine, therefore it equals a cosine squared. All right, that what tells me that if I just let x simply be the sine of theta and the dx, and therefore the cosine of theta d theta. All right, again, when I make substitutions, you know, this ought to clear up. But let's again, you know, focus on what does this function look like a little bit. Let me draw it down here. We've got this y is 1 over a root of a 1 less x squared. Certainly that's a 1 over a root of a 1 less x, 1 plus x. Well, what do I know? I know that at 1 or at minus 1 I get division by 0. Division by 0 again gives us this vertical asymptote kind of thing. Right? So I've got my axes here, then at 1, I've got vertical asymptote, and minus 1 in vertical asymptote. Well, I don't know, if you try 0 in here, if you're in between those asymptotes, gets just a value of 1. So it's up at 1, 0. You know, if I think of what happens as I put in values that get closer and closer to 1, you know, it would be the same moving this way as moving this way again, right? Because we're just the x squared in it. Again, it's a nice reflected curve, right? Even symmetry. So, you know, when I put in numbers that go from 0 to 1, what? I'm creating numbers that are between 0 and 1, but because they're being subtracted from 1, what I'm getting then numbers getting closer to 0 in here, but because they're reciprocals, they're getting closer to infinity then. Okay, so long argument, but it says, yeah, that the function runs up the asymptote. And by symmetry, I know it runs well in this direction. And then if you ask, well, what about beyond? Well, if you put a number bigger than 1 or smaller than -1, you're going to get a negative in the root, and so it's complex, and it doesn't show up on the graph. It only shows up as a complex picture, not as a real picture. So that's it. That's the whole function for our purposes. So the question then of going from 0 to 1 is going what? From 0 to here, but I'm going to what? I'm going to integrate to some b and let b approach 1. Right? Because I can't evaluate at an asymptote. I've got to push it to the asymptote instead. All right. So, you know, I know then that I should be writing this as a limit as some b approaches 1 from the smaller side. Right, from the left is that superscript negative there. Right, of an integral from 0 to b. Right, the function dx over the root of 1 less x squared. Right, now what? We've made all of this stuff here. Right, get the form, and so well, I should be able to then have some kind of a limit. Again, I'm not going to write the b stuff, or not write the integrals because it's all theta now. But what? The dx is just the cosine theta d theta. And in the bottom you have 1 minus the sine squared in the root. Well, what? The 1 minus the sine squared is cosine squared, but the root of it is just cosine. So just like the previous question, we have functions canceling, which again is why this is sometimes known by some of you as turned out to be an arc sine. anyhow, this leaves us with what, the limit of the integral just of d theta, so just like before, you've got a limit of theta. Alright, and then we gotta just go back and decide what theta is and write in that detailed limit to get the answer. So, now I'm gonna say it's really the limit as b approaches 1 from the left. Theta, from this, theta we know is the arc sine of x. So we have an arc sine of x, and we go back to the old evaluation of 0 to b. So, but now we write it out, limit b goes to 1 from the left, quantity, arc sine of b minus arc sine of 0.
You can just plug one in for, yeah, you just plug one in for inverse sine though.
Inverse sine. Well, I mean, yeah, any of them you can quote plug in if you know how to work the function. If you just, when I look at this graph, I mean, I know the angle whose sine is 0 is 0. I know another angle whose sine is 0 is pi. Another one is 2 pi.
With sine of b,
But you use the
1.
0 one. Again, if you want to, you can take this and draw the arc sine function, if you want, and then look it up as, right there is 0. Actually, they usually use just this part of it.
Well, it's more for the b equal
Well,
1.
right. So, where is the arc sine? In other words, either what? You're saying when this gets to be a value of 1,
You get pi
we're out here, so it's pi over 2. Or you say I need the angle whose sine is 1, right? And right here the sine is 1, so it is pi over 2. Either way. So, here then, the statement then for this is what, pi over 2?